Thank you very much for coming to the last session of the very last day. I know we are all quite tired already, exhausted. So the good thing is the topic is related to real-time multiplayer, but I'm not going to talk about the very deep technology, so you don't need to keep your sense to understand everything. It's just a story. I'm going to show up how I did for my own games previously. So don't worry about that. And yes, before dive into the topic, let me introduce myself. I'm Chris Song. I joined the game industry 30 years ago. It was 1995. And as you know, there was no Unreal, no Unity, so there was no graphic. My monitor was 14-inch CRT, very big, fat monitor. So even some colors here, it was not from my monitor. So it was some people from the rich guys. My monitor was green, totally green and black only. So that was what I was doing. I was a programmer, and I'm also still doing programming these days. I founded 3 different studios. Currently living in Finland, but I originally came from Korea. And back in Korea, I founded these 3 studios and ran them about 15 years. A little bit less than 15 years. It's not existing anymore. That means I couldn't get any money from here. And yes, I was a tech lead. I was a head, the studio head for the Smilegate, producer at NeoWiz. All these are the companies from Korea. And I was a tech lead, online tech lead for the Ubisoft, tech lead for the Metacore games. Those are in Finland now. A long time ago, I was also working for the Tentacle Studios. And yes, I also taught the students for over 10 years. Mostly was a part-time lecturer, but only in Singapore, the Nanyang Polytechnic, I was a full-time lecturer for 3 years. And I launched over 12 different mobile games, the 12 different PC console multiplayer games. Honestly, I never actually counted how many, because some of the games was launched, but just killed after the launch, or I helped out with the other studios, and then they just killed the game, something like that. So I don't want to count exactly how many projects I work on it. Also, these days I joined some of the mobile projects also. So it is more than 10 mobile games. And yes, as I said, I'm living in Finland. This is my new business entity, just started last month. CosmoUniverse. I'm working with my friends, very old friends. We are all back-end developer. We worked in the game industry for almost 30 years altogether. And we are kind of a, how can you say, kind of a individual consultants for the other studios. They are not under my company. My company is, I'm the only person. Each of them has their own business entity because we are living in the different places. One in Berlin, one in Singapore, the other one in Korea, blah, 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 something like that. So we are a bunch of friends of team staying in a bunch of different places and doing some work together. So let's jump into the topic. Latency. Okay. I'm very sorry about my throat. It's the last day, so a little bit painful. The latency. We know what is latency, isn't it? There's the delay, and this is one of the most pain point when we are working for the real-time multiplayer, because it's because of this latency, we call the game as real-time multiplayer, but actually it's not a real-time multiplayer, isn't it? Because there is some delays, there is some of the asynchronous issues, so But anyway, we need to overcome that. Then, before go more deep, let's just recap what is the latency. We know the latency itself. Yes, it's the delay between your device and the server. So there is some latency everywhere. But why the latency comes up? Isn't it like our packet, our data transmission is very fast, just like the speed of light. And speed of light is really fast. But unfortunately, our Earth is quite big. Yeah, somehow it's big, yeah. It's not big like a sun or any big planet, but yeah, it's big. It is, yeah, over 40 kilometers to go it over. And when the lights want to travel, cross over the Earth, yeah, it takes about 133 milliseconds. And as you know, it's like if your ping is go over 150 millisecond, 200 millisecond, there is some kind of a unhappy situation can come up, isn't it? Yeah. And let's say you want to make your gameplay between Rio de Janeiro from Brazil and Auckland in New Zealand, and your server is in Ireland. Yeah. No one tried to build this kind of infrastructure for the real-time multiplayer, but just let's assume. There is a distance, 27,000 kilometers, so round trip is 54,000 kilometers, and it takes 180 milliseconds, only for the light. Yeah, not calculating anything else, just the single straight direction distance takes 180 milliseconds. So there is latency, yeah. And as you know, these days, your monitor or even your mobile phone maybe support 144 megahertz. Yeah, this means, isn't it? Like each of the frame is flicking in 6.9 milliseconds, about 7 milliseconds. That means if we bring this 180 milliseconds into your screen, one packet will skip 26 frames of your game. Yeah, isn't it? Like when you play the game, sometimes we complain, okay, the game is not keeping the 60 FPS. Yeah, like, oh, my games are too slow, 30 FPS only. You can receive only one packet if your game is running in 30 FPS. Yeah. So this is, even this is not counting any extra delay, only the speed of light. So yeah, the latency is there. And not only that, as you know, internet is quite complicated. It's really big, it's huge, complicated. And there's a lot of devices everywhere, routers, switches, some IDCs, yeah, everything. Yeah, so there is even your packet is not going straight forward into one direction. Yeah, it's going to flow somewhere, just jumping around. So, yeah, it's quite complicated, and it takes time. Yeah, every devices give you latency. Yeah, and not only that, when you press the button on your device, there is a processing time, isn't it? It's like it's very slightly small, but yeah, still there is a processing time. So this also can generate the delay. Yeah, and so if your game makes some delay in your game loop or rendering or somewhere, then yeah, you need to count in that as a latency, because anyway, you will receive the packet in everything happened after. So yeah, there's a bunch of things we need to combine. So if we calculate everything, then probably you can see something like this. There is a processing time. You need to go through the internet. There is a servers. These days, there's not only the single server for the game. Yeah, there's multiple different servers, the databases, and I believe your game is not only using single database. Yeah, the multiple different databases. If there's a proxy, then it have to go through there. Yeah, and it also need to come back. Yeah, I'm not just only going to ping to the server. You need to receive the packet. So yeah, if we calculate all these, yeah, plus, and Yeah, if you are using the mobile network, there's a more. So, okay, this is real world, physical world. And I found out some people are complaining like, okay, why this game has this big latency delay issue? Yeah, this programmer is really bad. Yeah, you hired the very poor programmer, but you can see we cannot overcome this. This is speed of light. Yeah, you need to complain to the Einstein, isn't it? Yeah. We cannot overcome this. There's no way. Yeah, this is existing. Then how we can make a better game for the player? Okay, so that's what I focused for last decades. And yeah, the main point is, okay, then how I can deliver the better experience to the player, even there is a latency. So more fair topic is the fairness of gameplay experience to the player. Yeah, I brought 5 topics here, 5 maybe tips or topics or yeah. I don't like the tips. Yeah, because sometimes I feel like when I read the other people's articles, it says tips, blah, 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 and I think, okay, how can I apply this to my game? It's not a tip, it's an idea, but sometimes it's not really working for me. So yeah, let's say like this is topics and idea. So I will give you the idea what I really actually implement into my games. So the first one is pre-action. Yeah, pre-action. Every action, if we want to kick the ball, you need something to do before that, isn't it? Like you need to swing your legs. Yeah, you need even here. Oh yeah, I really love this goal. Yeah, it's my favorite football player, Son. Yeah, Korean football player. Yeah, I really love this goal. You can see there is a few meters of distance, run, and then swing your leg, and then kick the ball. So your actual action of the gameplay is kicking the ball. But there is some action, pre-action, before kicking the ball. That means you still have some time to synchronize your data and everything. So you don't need to worry about the latency immediately happen. Yeah, because there is a pre-action every time. Even you throw the ball, there is a pre-action, isn't it? Yeah, even you sneeze, you need to breathe in. So actually, it's like every time I'm talking to my team, this is kind of a breathe in before sneeze. Yeah. So how can you sneeze without breathe in? Maybe some people can do, I don't know. But I believe that's the very normal process. So please think about this. Yeah. So I'll give you the actual practical example what I did. Here is the game. The orange one, yeah, is the game. And the green one is the other player. Yeah, and so this is your device, the other players, and there is a server. So when you press the screen, yeah, when you press the button, touch the screen, yeah, pre-action is going to start. Not the real action yet. Yeah, pre-action starts, and it will give you some time to send your packet to the server. And when the server receives the packet, process it, and then return to the others, yeah. And then in the meanwhile, the main client, your screen will show up some pre-action, like a VFX. Yeah, isn't it like an RPG? There is a fantastic some VFX coming up. Yeah, prepare everything. Yeah, you can imagine like a Final Fantasy. Yeah, just I didn't play Final Fantasy VII Remaster yet. Just my friends was just joking me, you are the loser. But anyway, yes, yeah, there is a lot of VFX you can bring it out. And then when it looks everything is ready, yeah, then you can go on to the real action. Yeah, as I said, when the speed of light goes through the world, the Earth, it takes 180 milliseconds. I believe quite a lot of your pre-action could take more than 100 milliseconds. Yeah, 100 milliseconds is a really short time for us. Yeah, sometimes it's really unnotable time. So yeah, you can try to think about this A few months before I read the article about the Tekken, how they synchronize all the actions, and also they did something similar like this. Like the pre-action for my screen, there's our example, like let's say there's our 15 frames. Yeah, the other players, you can see the time delay is a little bit short because it's going to receive the packet a little bit later. So skip some frames, and then, 15, let's say original frame is 15, then put that into 8 or 9, and then show up the real action after that, something like that. So yeah, this is the one trick every time I'm trying to put it into the game. Second topic, yes, time synchronization. This is really important, isn't it? Like, because we believe we live in same time space. But once more, Einstein figured it out, okay, we are not living in the same time space. Yeah, we are having a different time space. Yes, thank you very much. We're not, actually, I don't know how we can interact each other. But anyway, yes, we need to synchronize the time inside the server to make everything correct to everyone. Yes, and I believe the second one, the lag compensation, that is one of the most popular way to synchronize time. Yeah, because that was introduced by the Counter-Strike over 10 years ago. Yeah, you can find out the video from the GDC, how they made this. Not only the GDC video, yeah, there's a bunch of the YouTube videos you can find out related to this one. So yeah, this one is quite well known. I'm not going to talk about that. I'm going to talk about the next one, because most of the game, isn't it? Like, we don't need to really understand exactly when you did what. Yeah, like an example, like, okay, you and I try to hit each other, and then, yeah, my punch started in exactly 1 minute, 00 something millisecond, yeah, blah, blah, blah. We don't need to understand that sometimes, yeah, isn't it? Yeah, if I can understand, I hit you first, then, yeah, usually the game says, okay, this guy win the game. Yeah, so this guy, we give a priority, and the other guy will lose the HP, something like that. So we don't really need to understand the time gap is 10 millisecond or 100 millisecond or like even a 1 second, something like that. Yeah, sometimes if we understand the sequence of the event, then that is quite enough. So yeah, this one is one of my best every time. I like it. So average round trip time. Probably most of you already know what is the average round trip time. Yes, something like this. So yeah, you can see the device A has round trip time like that, A. Device B has round trip time B. So actually, the A has a better network. Maybe he paid a little bit more. I'm still using the cheap internet, and I only have the low bandwidth. And my wife has better phone than me. Yeah, she's a new iPhone, so she has 5G. I don't have 5G. Yeah, so B is my wife, and yeah, A is me. Yeah, sad. I want a new phone. Anyway, yes, sorry about it. Yeah, so when there is action from A, yeah, let's say this person press in that point. Probably it will arrive in the server in this point. Yeah, is it? And B press the button here, and probably it's going to arrive here. Yeah, in the server, if we only check the arrival time, then it will say, okay, A did something earlier than B. But if we calculate round trip time back, yeah, then we can find out, oh no, okay, B actually did something earlier than A. And it doesn't have to be very accurate, because round trip time is not 100% accurate, because every packet has a different trip time. So yeah, we cannot say that is 100% accurate, but we can assume, okay, probably B pressed earlier than A, and most of the time, this is correct. Yeah, because it's like if you are checking, okay, one thing is, if you check only one round trip time before something happened, then probably that will not be very accurate. But if you trace the round trip time through your gameplay, then it will make a better assumption when it really happened before. So you have to trace the previous round trip time. So then, yeah, now we found out, okay, B actually pressed the button earlier than A. So, okay, let's give it the priority to B, not A. So now we know, okay, who punched first, or like who shoot the gun first, or yeah, who did what first. Yeah, so then now we can make a better kind of a game process for the player. Okay, so the third one, this is the camera work. I brought this because most of the real-time multiplayer game is really difficult to make a fast movement because of latency. If your object moves too fast, then the error through the network will generate more big difference between the different players. So how can I say, like, isn't it like, let's say you are working on the racing game, and then your car is super fast. Yeah, then even a 1 millisecond can make a big difference. Yeah, so there is a limitation. You need to find out, okay, how fast your object can move in your game. But mostly, it's not really, it's kind of it's not easy to make the golden ratio of your movement speed. So let's try to use a camera work, then the high-speed work. So these are the game what I worked before. And you can see there's a lot of camera movement, camera shaking. Why I put this? Because I wanted to hide the latency. I wanted to give a better feeling of the fast movement to the player, not only static camera. Yeah. Example, like you can imagine 15 years ago, the movie, when there is a movie just trying to take the film with driving on the car, then isn't it like these days we really can drive the car and put the camera on the car. But 50 years ago, maybe longer than that, but yeah, the car was in the studio, and then the background was rolling back, something like that, isn't it? Yeah, that was what really happened. Why don't we try to think about something similar like that? So this is how I did. There is a camera on your character, but when the character starts to move, not the camera moving exactly same as the character, try to make some delay, kind of a force there. And then what could be happen? Yeah, the actual movement of your character is distance A. Yeah, this amount of the movement happened. But on the screen, because of the background and everything, the player can feel like, okay, my character moved the distance of B. Yeah, isn't it? Yeah, so it's giving a better feeling of the fast movement. Yeah, even it accelerate more. Yeah, you can expect now, isn't it? Like actual movement is BA, but we can give the feeling of the movement just like a B, distance of B. So this is some kind of a camera trick to reach the better experience to the player. Even the character movement is slower. Yeah, when the character is decelerating, yes, also try to push the camera a little bit more. Yeah, so there is some force. And then, yeah, you can see the actual movement of the character is A, but yeah, on the screen, the player will feel is much more faster decelerating because it feels the movement is only B. Yeah, something like that. Even it stopped, when you stop the character there, yeah, why don't you just push the camera a little bit and then bring it back, or yeah, something like that. Some kind of a camera trick. It can give you some time of delay to correct your errors and everything. You can recalculate the location of the character. So actually for this one, isn't it like quite a lot of time from my experience, the starting of the movement of the character or object is a bit easier to synchronize. But when it tried to stop, yeah, isn't it? Because of the network latency on the screen, let's say your character stopped here. But there is a latency, so yeah, the other screen, you can see the character move a little bit stop a little bit later, something like that. So then we need to synchronize this into one single position, yeah, based on the calculation. Then this kind of a camera trick could help you, yes. And number 4, the design also need to work together. There's a bunch of wording. Let's just skip that. I'm not good at reading. Yeah. So, yeah, this is also the games, yeah, the same game I showed up. So kind of a wide area attack could help you because it's like if your bullet is one single point, it have to be very accurate. But if it's a little bit wider, if there is an area, then yeah, it will be a little bit relevantly easier than just one single bullet. Yeah. And this one, the homing missile, I can give you an example, like when you see the enemy on your screen, yeah, and you try to shoot the missile. Yeah, let's say your missile is not only going straight way. Straight way is a different thing. Yeah, that's a different thing. But if you make some kind of this kind of a curve or the homing style, then it can give you some kind of tolerance to the gameplay. Yeah, so let's say that if in this case, probably on the opponent screen, the other player's screen, the character could be in the different position because what you see is a little bit later than the other. So you try to shoot the other, that means you are trying to shoot the past of the other player. Yeah. And then the server also could have a different location of the character. Yeah. So everything is different. Yeah. Einstein's correct. Yeah, then when it goes up to the other, if the missile can make a curve, then yeah, your screen, it goes to the red line, but on the other screen, you can still make it to curve a little bit more to hit the actual player on the other screen too. Yeah. So this is when it happened, the hit detection, yeah, decided everything hit it. If the hit detection says, okay, you missed the missile, you missed the enemy, then just make it pass through the missile. Yeah, you don't need to make the big curve or try to trace the character. So yeah, this kind of the missiles or obstacles, I really love to put it into the game. Like even sometimes I feel like isn't it? When I was playing the Diablo fireball is just going straightward. And even this fireball didn't hit the skeletons. Yeah, skeletons just die there. Oh, yeah, I did another magic to kill the non-hitted skeleton. Yeah, that's coming up because of this reason, yes. But this one, we need to be very careful because this is going to affect the actual player feeling. I mean, hit or not is really critical, isn't it? So yeah, I gave you an example, but don't try to put everything just exactly like this. You have to think about some edge cases, like when the opponent is very close to you. If you don't have enough time to make a curve, then what will happen? Yeah, if you have some missiles with some kind of a tracing, but you want the other object. Let's say when the other object interfere the line of your curve, then what will happen? Something like that. So you have to think about something more when you try to really implement into your game. So the last one is, yes, more effect. More effect, more effect, more effect. This one is also one of my favorite. It's okay, let's talk about the audio. Audio is just going to give, as you know, the speed of sound is slower than speed of light. So we already know when there is something moving, like a jet or some fast movement. Actually, there is some movement. There is some sound coming later than your visual, isn't it? So yeah, this one you can adapt into your game. Your audio doesn't need to be very same position from your character on your screen, because we already know the sound is coming a little bit later than your visual. So that is quite normal. But this one, I want to talk a little bit more about this. Hey, come on. Oh, okay. I'm sorry. Maybe the few slides are missing here. Maybe I gave the earlier version. Yeah, on the slide, you can see the stream of the laser. It has some gradation. Yeah, it's not in the middle. It's most bright, and then there's a gradation. This, I put something like this, is if you have a very clear cut, it's same as a one single pixel bullet. Yeah, if there's a clear cut, if the other character has a tippy toe on that clear cut laser, then everyone knows, okay, oh, this is hit it. But if you have a gradation like that, yeah, oh, is it or not? Yeah, it's very difficult to understand the clear hit detection from our eyes. So because of that, it can give us some space to calculate it is really hit it or not. Yeah. So the main idea is don't try to give a control of judgment to the player. Don't let the player to think about, okay, this is or this is not. It's okay, it looks like it's the best way. So because your server and the game client is different. Yeah. So every time, isn't it? I'm very big fan of football, and I know some judges in the football, especially in Premier League, they're not really good. Yeah. And it gives me feeling okay, that judgment is wrong. Yeah. Or that is really good judgment, something like that. Yes, we do that, but don't try to give the control over the player. It's just give them a kind of a feeling. Okay, this is correct. This is always like this. So it will be something like this. So give the feeling of the judgment, not the control of the judgment. That is the main point every time. So the key takeaway here, yes, latency itself, we cannot overcome. Yeah. The title of my presentation is Overcoming the Latency, but actually my takeaway is we cannot overcome that. Yes, it's combination of everything is there. Oh, sorry. And all other elements you have to combine in to the game. I mean, not only, don't blame the programmer only. Yeah, I'm very painful every time. Yeah, I'm very difficult to stand for this. Yes, so yeah, your designers, your artists, and your all elements of the department of the game developers have to work together to make a better real-time multiplayer game. And yes, try to give the experience of fairness. Yeah, it's not, we cannot be 100% accurate, but at least if we give the feeling of this game is fair enough, then player will understand. Yeah, that's what I learned from my previous games. Yes, thank you very much. Yeah. Yeah, if you want to talk anything more or any question, yeah, let me know.
Yeah, questions are welcome. Okay. I've got a question, actually.
Yeah.
Are you aware of any techniques to pretend that the game is fair if it's a racing game and it's not a question of a decision whether there was a hit or not, but you can, when you present the player that an object changed its position, then it's still moving from that position, and well, it's some lerping of the position to calculate it on the server. Does it always help, or are there any clever techniques?
Okay, sounds like you're talking about the extrapolation. In one of the very well-known technique of calculating the position, not only the racing, also with the real-time multiplayer, there is a dead reckoning. And this dead reckoning has two calculations. One is interpolation and the other extrapolation. Extrapolation is trying to anticipate the future. Interpolation is trying to calculate the trace of between the two different positions, so something like that. So when the racing game, yes, the extrapolation is really important because, as I said, movement is very fast. But the good thing is, the racing is, yes, especially for the racing, the good thing is, as you know, the car cannot curve in 90 degrees. That is really important. When you drive, isn't it? Like I guess most of you drive. So when you drive 10 kilometers per hour, or even 100 kilometers per hour, when the car comes beside you, you already know it's not going to crash me. Because mostly we cannot, if you're taking a movie to do this, then yeah, but it's like a big truck comes very close to you, it will go just ahead. Yeah, that is what we can calculate for the racing game. So yeah, every time the issue is not the error between the different direction. Mostly the error is acceleration and deceleration. Yeah, and that one is also quite predictable, kind of. Isn't it? It's like when your object is running for the 100 kilometers per hour, it cannot drop into the 1 kilometers per hour immediately, something like that. So the racing game is using the very heavy math to calculate everything, something like that. And yes, because of that calculation, sometimes it makes some mismatches. Yeah, so that's why it's like when the racing game, it can flick on the screen, yeah, or like jumping around a little bit. But mostly that, from my point of view, I don't know, I never developed the racing game by myself, so I don't want to say too much, but it's like, yeah, from my point of view, if you have a good interpolation and extrapolation calculation, then it could be better, yeah.
Actually, I've got one more question, because you said that you've been developing multiplayer games for quite a while, and the bandwidth is improving over time, but also the games are more complicated. And was it easier, or is it becoming easier to overcome this latency? Latency
issue. Honestly, it's getting better because the network is getting faster. Yeah, that is much more better. Yeah, it's 30 years ago, I was using the dial-up modem. It was 9.6 kilobps per second. Yeah, not like 100 megabytes 100 megabps or not like that. It's like only 9K. Yeah, even I used the 4.8K. But anyway, yeah, it was very difficult to work on those kind of environment these days. But these days, as you know, it's like even at home, yeah, some places you have a terabyte. The gigabyte internet, something like that. And it's getting very faster. And even the mobile phone, 5G is really fast. So my point of view is don't need to worry about the infrastructure. It is already there. And honestly, if you pay more, you will get the better infrastructure. Like if you pay more for your AWS, then you will get more bandwidth. Then that means you can more concentrate into your own servers, your client, your network system, your softwares. So for me, I feel it's getting better.
Thank you. Are there more questions? If not, then thank you. That was Chris Hong from CosmoUniverse.
Thank you very much.